so let's go to page 299, 5.1. Idea of probability. So what exactly is a probability? So a probability, if you go to page 300, actually not 300, 301, it said the probability of any outcome of a chance process is a number between 0 and 1, because it's a probability, right? You can't have a negative probability. You can't have a probability that's greater than 1. That describes the proportion of times the outcome would occur in a very long series of repetitions. Okay, so a very long series of repetitions. What that means is this. So if I wanted to find out what the probability of landing a head when I toss a coin is, okay, I'm going to go ahead and do an experiment, and I'm going to flip the coin for 10 times. So if I flip the coin 10 times, okay, if I flip the coin 10 times and I got 6 heads, okay, and 4 tails, okay, that means to me that the probability of receiving or getting a head is 6 out of 10, which is 60%. And the probability of me getting a tail is 40%. Okay, when truly, if it's a fair coin, what is the theoretical probability, right? The theoretical probability is 50-50, right? It should be 50-50, but the experimental or empirical probability shows that out of the 10 times I did it, I got 6 heads and 4 tails. Okay. Now, if I did it 20 times, I might get a different result, right? If I do it 20 times, maybe I get, I don't know, 11 and 9. Okay. So then my probability of getting a heads would be what? My experimental probability is 11 out of 20, which is 55%. Heads, 45% tails. Okay. So if I do this enough times, right? If I do this enough times or many, many, many times, right? You would think that the experimental probability, all right, the experimental probability would approach or get close to the theoretical probability, right? Or it should. And that is actually shown on page 300. You can see that as, you do this, it does so many times, right? And how many times they did it on this one? On this, looks like they did 10 times. They did the flip the coin 10 times, right? Okay, so if you go to page 301, all right, as you go and you do the number of tosses, and the number of tosses gets close to out to 500, that's when it really kind of gets closer to, approaches, or it takes that many times for the experimental probability to reach the theoretical probability, right? So we always call this, another thing that we call this is the law of large numbers, okay? The law of large numbers. As n goes to infinity, as the number of trials goes out, as long as you do many, many, many trials, the experimental probability will go closer to the theoretical probability. And that's on the bottom of page 301. There's a green box that says the law of large numbers says that if we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches its probability, okay? So what's happening earlier? What happened here? Okay, what happened here when we did I got like 6 heads, 4 tails, or I got 11 heads and 9 tails? What happened? I just got unlucky, or it was by chance I did not get the exact theoretical probability, right? So let's go to the example, who drinks coffee? It says, according to the Book of Odds, the probability of a randomly selected US adult drinks coffee on a given day is 0.56. So A, interpret this probability as a long run relative frequency. If you take a very large random sample of US adults, you will see that 56% of them will drink coffee that day, okay? B, if a researcher randomly selects 100 US adults, will exactly 56 of them drink coffee that day? Not necessarily, right? There is a chance you get a bad draw or you get an unlucky thing, right? So it's not going to be 56, it's going to be, could be 58, it could be 64, it could be 75, all right? You never know. Probably not. With only 100 random selected adults, the number who drink coffee that day might not be very close to 56. Okay, that makes sense. Let's move on, and then we go to where it says simulation. Okay, hang on a second. Okay, so that is, okay, so we're done with part one. So we're done with part one. So let me go ahead and